everyone, I am Princess Lyka and Viernes from Grade 11 Aquamarine under the advisory class of Ma'am Marie Chris M. Carino. In this video, I will be discussing the zeros or the X-intercept of irrational functions. But before that, let me first show you the objectives of our discussion. First, define and determine X-intercept in rational functions. Second, solving X-intercept and zeros in rational functions. And lastly, locate X-intercept in graph. So what is intercept anyway? The intercepts of the graph of a rational function are the points of an intersection of its graph and axis. How about X-intercept? The X-intercept is the coordinate or the x-coordinate of a point where a line, curve, or surface intersects the x-axis. Also, the zeros of a function are the values of x which make the function zero. The numbered zero are also the x-intercepts of the graph of the function. So, take a look at the picture given on the slide. The vertical line is our y-axis and the horizontal line is our x-axis. And there is a line that intersects our x-axis. And the point of their intersection is what we call the x-intercept. So, did you get it? Now, let us go on in finding x-intercept in rational function. How to find x-intercept in rational function? Okay. In finding x-intercept, you need to equate the function to zero. And then, by symmetric property of equality, multiply both sides by the given denominator. Then, apply addition property of equality. And the next is simplify your answer. And the last step, apply multiplication property of equality if needed. Okay, so let's solve. Given the first example function, f of x equals 6 minus x over x plus 2. So the first thing that you are going to do is that you have to equate the function to 0. So that will be 6 minus x over x plus 2 equals 0. And then, multiply both sides by the given denominator. It will be like this. The quantity x plus 2 times 6 minus x over x plus 2 equals 0 times the quantity x plus 2. And that will give you an answer of 6 minus x equals 0. But how did we get that answer? As you can see, there is a common factor which is x plus 2. So we will be doing the cancellation process. That is why we get the answer 6 minus x equals 0. Okay, next step is that you have to apply addition property of equality. So, 6 minus 6 minus x equals 0 minus 6. Then, simplify your answer and that will give you an answer of negative x equals negative 6. Since there is no answer negative x, you need to apply multiplication property of equality by multiplying both sides by negative 1 to make it positive. Okay, so negative 1 times negative x equals negative 1 times negative 6. And that will give you an answer of x equals 6. And that is our answer for that function. Another example. G of x equals 12 plus x over x minus 3. So, we will be doing again the first step. Equate the function to 0. 12 plus x over x minus 3 equals 0. Then, multiply both sides by the given denominator. So, the quantity x minus 3 times 12 plus x over x minus 3 equals 0 times the quantity x minus 3. And that will give you an answer of 12 plus x equals 0. Again, we applied the cancellation process to get the answer 12 plus x equals 0. Then, apply addition property of equality. So, 12 plus negative 12 plus x equals 0 plus negative 12. Then simplify your answer. And that will be x equals negative 12. Since x is not a negative anymore, we will not applying the multiplication property of equality. And the answer x equals negative 12 is the final answer for this function. And that will be all in finding x-intercept in rational functions. Now, let us go on in finding the zeros of a rational function. So, how to find the zeros of a rational function? Okay, given the example letter A, L of x equals x minus 3 over x plus 1. So the first step that we will going to do is equate the numerator to 0. So x minus 3 equals 0. And then solve for x by applying addition property of equality. So x minus 3 plus 3 equals 0 plus 3. And then, simplify your answer. And that will give you an answer of x equals 3. Thus, the zero of L of x is 3. That is our answer. Next example. G of x equals x minus 5 over x squared minus 25. So, the first step is that simplify by factoring the denominator. Since x squared and 25 is a perfect squares, we will be doing the factoring method difference in squares. And that will be x minus 5 times x plus 5. Or the quantity x minus 5 times the quantity x plus 5. And then, remove the common factors by cancelling. And that will give you an answer of 1 over x plus 5. And then, equate the numerator to 0. So, 1 equals 0. And 1 equals 0 is a false statement. So, there is no 0 of the function, which means that no point on the graph touches the x-axis. And that are the methods in finding the zeros of a rational function. Now, let us jump in locating x-intercept in graph. In algebra, two-dimensional coordinate graphs have a horizontal axis or the x-axis and a vertical axis or the y-axis. The places where lines representing a range of values cross this axis are called intercepts. So, in order to find the x-intercept in graph, you need to first identify the x-axis and then find the point where line crosses the x-axis, and then write the ordered pair for the x-intercept. So, given the example graph on the slide, according to what I have said before, you need to first identify the x-axis. So, our x-axis is our horizontal line. So, this is our x-axis. And then, find the point where the line crosses the x-axis. So, as you can see, this is the point of their intersection on the number 4. And last step is write the ordered pair for the x-intercept. So the point of their intersection is the number that we will going to write on the ordered pair. So the ordered pair for our x-intercept is 4. Since we are not finding for the y-intercept, we will just simply write 0. So, our ordered pair is 4, 0. And that is the process in locating x-intercept in graph. To summarize all of that, the intercepts of the graph of a rational function are the points of intersection of its graph and axis. And the x-coordinate of a point where a line, curve, or surface intersects the x-axis. Lastly, the numbered 0 are also the x-intercepts of the graph of the function. So that will be all for this video. I hope you enjoyed watching and learned something from our discussion. Again, I am Princess Lyka and Viernes from Grade 11 Aquamarine under the advisory class of Ma'am Marie Cris M. Carino. And this is